Welcome! Welcome to part one of our little MMX MMU journey. Hi there, John. Hi there, Patsimir. Welcome to the stream. So, yeah, enough CNC stuff for now. So, we want to put together this MMU kit. This is the Triangle Labs kit for the MMX MMU. I think I paid around 60, 55, 60 euros, something like that. And the kit includes everything you need to put it together. Hopefully, we will find out. So basically it comes with all the hardware you need. There's an extra, you don't need that yet, but extra Bowden tube. There is quite a lot of hardware. We have LEDs, some cables, belts. These are not gates, but will be good enough. Very weird small zip ties. These are like bearings. I think these are like all the extruder parts. Then we have one big bag of screws. We have, what type is this? MG996R servo motor. So this one will drive the camshaft that selects the active gate. So this is also here. Then, and I think it's kind of like a newer addition to the MMX. I think it's not a brand new kit, so like not a brand new project. But basically, like the earlier versions powered the stepper, the servo motor of the tool head board, or like the main board of the thing directly. But seemingly it's way better to power it externally with this 5-volt or like buck converter with 5-volt. Then let me actually unpack that. We do have a NEMA 14 stepper, if I'm not mistaken. Yeah, that's a small NEMA 14 stepper. Oh, and they even give you a heat sink with it, which I guess is nice. We can install it. And you can crimp a different connector on here. Okay, so it's a Triangle Lab branded stepper. Not a very powerful one, but I think that is more than enough for what we want to do. Throw it out right away. Then we do have actually two. One I already inserted here in the selector thing. I miss it right now. So we have two 5mm rods. We have one 3mm rod and two M3 rods as well. That will later hold everything together. That's the hardware. We have a bit of Bowden here, which is actually used for the hinges of the gates. And last but not least, hi there, Mr. DSI, welcome to the stream. Last but not least, we have an EBB 42, which will be the brains of this entire thing, so to say. I will link this with Canvas to the printer. So yeah, we will not use USB. It's just Canvas. We have Canvas already set up, so that's by far the easiest to do so. Actually, not sure if I have a USB port still free, so we will need a USB hub there. We do need a Canvas hub, which will be built with some Wago clamps. So this is great. The only thing we need to check is because basically I only want to have one cable here, obviously, so the cable goes in here. But we still need to power the buck converter somehow. So we need to steal 24 volts from somewhere. I'm actually, I don't want to like solder anything or something. So my idea was to use the hot end connector here, basically, and just in the firmware configuration, just to set it on by default. So that would be like, because then you can just connect it here with the screw terminals and you don't have to solder anything. You get like clean 24 volt out. So I think this is kind of what I want to do. So yeah, that is for later. I'm not quite sure how long this will take to put together, to be honest. Um, it's not as crazy as ERCF for sure, but it's still like quite a lot of like stuff to put together. So I'm not sure if we manage everything today. That would be my goal, but let's see how it goes. Um, what will catch fire first? We will see. Are you going to use a filament buffer? Um, the actual answer is no, because so for me, I'm building this less for using it. It's more like to develop my app with it, to be honest. Like this is just like a playground in a certain sense. I just need like a multicolor printer. So I don't think it will see a lot of daily use. Like I sometimes print like stuff with multiple colors, but it's like very rare. And usually small parts. So I will not use a filament buffer, but I hope we will manage to put it on the Switchwire in a way that the filament is fine. The main reason why I don't use a filament buffer is I don't have space for it. I want to keep the printer in the same footprint. And with that, I don't really have the option to add a filament buffer. It's just like storage constraint I have at the moment. Like I'm running out of space, to be honest, with printers. So no filament buffer for this very simple reason. Okay, cool. We do have a manual, which has the lovely draft written all over it. And I already noticed it's outdated. It is not matching the parts I have in a couple of spots. So I think there was some revision at some point and this manual was never updated, which is fine. Like I just want to use it as like a rough guide. It's also like not really like a step-by-step manual. Like it's not like your Voron style manual. It's a little bit more like a high level. So the first just goes over all like sorts of description, which we don't need for now. The bomb is not correct. Or the bomb is correct, but it doesn't match the steps below. These are all the print parts. So I printed everything. I printed in ABS and PLA. So on the printables, it said that the camshaft and the idler doors. So the camshaft is this one here. This is the camshaft. And the idler doors. Let me just clump this all out. The idle doors are these, and this is actually the same yellow filament I used on the Switchwire. I had like, I don't know, like literally this much left. Like I printed this and I had like a meter filament left. So it was just enough. So it was kind of like a one-shot kind of like situation. And the filament was horribly old. I'm not quite sure when I built the Switchwire, but I think it was like 3 years ago or something, and this is how old the filament was. So I dried it like a lot, but then it was still like a little bit brittle, but like it printed fine. So no complaints there. I printed those on the Satsuma, the printer we built last. Oh yeah, and then these are the LED diffusers. These are transparent patchy, 4 of those. Yeah, so the printed parts, I hope I didn't miss anything or that there was anything that I should have printed that was not clearly described to be printed. And yeah, printing was relatively straightforward. You do need supports, like for the camshaft for sure. I'm not sure if you can, you don't see it now, it's behind the chat, but like basically it's like the camshaft you print standing. But also for these, for the gates, you need support. So it's definitely designed with supports needed. And yeah, this one is, I'm not quite sure, like somehow this is linked to the SV08. I'm not quite sure how, but like the official mounting solutions for the SV08. So we need to come up with something to mount that to the Switchwire later. And yeah, that's a little bit the mechanical overview. So basically we have this very big void with the stepper, the servo, the electronics here. And then on the side, we have the mechanics, so to say. The servo is driving the camshaft to select the gate, and the stepper is basically just like extruding the filament. And yeah, that's kind of the side view, so you don't see it again. So you have this like big drive gear, which is like a 80 tooth gear, if I am not mistaken, which I actually have as a metal gear. So potentially we could also just use the metal gear, so the printed one. Mm, actually, let's do that maybe. I mean, I literally have it a gear, so why not use it? Yeah, that's the top view. So we have the gates 0, 1, 2, 3. And I think this is kind of where we need to start off. So these are the heatsink inserts. And I think that's a great first step to to get started. And I think these are these two lovely parts here, which are full of heatsink inserts. Let me quickly see that I get that right. Oh wait, this is only one part. This is only this part. It's this side and then it's that side. And also like the holes did not print very cleanly. Like, I mean, it's serviceable. We can clean this up, but like the holes, because it was printed basically this way around, the hole overhangs did not print nice. They do use this trick that I also use with the cross bridges, but for some reason this did not turn out so great. But yeah, it will. I will. We will clean this a little bit. But first the insert. So okay, let's start. I see 1, 2, 3, 4. 5, 6, 7. And then on the side we have 1, 2, 3, 4. Then on the inside, no, that's it. They show the heatset inserts on both views basically. Okay, so it's mostly on this side here. Let me see. I didn't sort these hardware things because I figured it's not that much hardware this time. So I will just use the bags here, and when we're done, I'll put it in my crew storage. Okay, and I think the heatsink inserts were in this one here. Yeah, I see some more hardware coming out. So we have washers, we have some lovely magnets. We have some M3 nuts, bearings. Oh, that's interesting. That there we have to pay attention. So there are like two heated inserts with M3, diameter 4.6, length 3, RS2, and length 4, which are the Warren standard, is like this bag. The manual calls for these now. No? Let's just use this here. So let's just get that right. It's not this hole. It's this one. Let me give this a bit more temperature. So it's this one. It's this one. And it's this one. And then this one. And then these three. And then the ones on the side. Okay. I think that is all. Ah, there we missed one. Okay. Then where are you hiding? Oh, this part's over here. So this looks a little bit different from the manual because, like as I mentioned, like this buck converter was added later, and so the manual is not up to date there. Okay. And then later sliding in here. And similarly, this screw here. This screw here, there's a little hole here, so I assume we use a slightly longer screw for this one to lock this in place. Okay. Um, Now, which part is... Oh, this is this part on the side there. So we have 1, 2 here, and then 1, 2, 3, 4 on the side. And then I hope we are done with heatset inserts. I mean, like, I have tons of them, but I think the kit is at the end of heatset inserts. And then these two. Curiously, these two look exactly like heatset inserts, but we have only 2 left. Maybe these are the short ones. No mention. Like this is it. So we do have these 2 short ones here, and there are 2 holes here that do look a lot like they would need a heatset insert. But I will hold out and see if they need to go somewhere else. And then we can later put them in. Okay. Then they just show us the whole like mechanical assembly here. So this is kind of what we have to build. So there are basically 4 pairs of BMG extruded gears in here. Hi there, Hannes. Welcome to the stream. We are building an MMX MMU, so a multi-material unit, which is like a sweet little kit. Relatively simple for an MMU. Maybe cut files are up to date. That's actually also a good idea, and I have that, of course, prepared. Oh, it does that again. 1 second. Sometimes the fusion sharing just freezes. Yeah. No, which part is that? That's the end on the other side. It's this one here. I'm not sure if they model screws here. I mean, there are definitely 2 heatset inserts in here. Which is body 40. um, Let me see. Yeah, but it doesn't tell me like what this is. And because the body, I cannot isolate it, of course. What did we say? 40 it is. 0.05 meters. It's a very, I think Fusion is a bit drunk. Like, why meters? Can you give this to me? I mean, it's 5 millimeters, but like, why tell me that in this like odd way? Um, that's not helpful. But definitely there needs to be heatset inserts in there. And honestly, like the only heatset inserts I have left are these. And I don't think we have, I mean, it can't be anything on the gates because we have 4 gates and 2 heatset inserts. So it must be. I don't see any other heatset insert spots. So I think they need to go here. Let's just roll with it. Inspect and measure, yeah. But it measures as 5. But I don't see the reason why you would use shorter ones here. But like it's the only spot not mentioned in this document. Because here it's like they're just empty. They're not like it's in the model. Used. It's weird. Yeah, let's just put them in. Here you go. Might regret it later. Maybe not. Okay. So when I said like the manual is not really like step by step, this is what I meant. Like it's very much, it just shows you how to like what goes where, but like it doesn't really give you the order. So heatset inserts are in. This is the mechanical assembly we want to build, of course. The project configuration, I think you can, it's better too short than too long. Yeah. Um, so this kind of the mechanical system we want to build, but then it's not really like clear like how to do that step by step. So I think what we should do is we should assemble these gates 4 times because we have now all the parts. We can technically put it together. Let's just start with 1 gate and figure it out. So the basically how it goes together is we also have to remove some support still here. I didn't do it yet. So we have 4 gates, and in between the gates we have these spacers. So they basically go in like this. 3 spacers, 4 gates, and then you kind of smash it together. Um, and then this kind of is how it fits together. Looking at that now, oh, in the cat is the other way, or like this image is the other way around. It's like this. Okay, well, yeah. Either way. So we have basically 1 bearing here on the side. We have the ECAS on each side. We can add them at the end. And then we have the extruder gears. So let's just put that together. So we have this M5 shaft that basically goes through all of them. I believe these are the bearings that go in here. They do fit, so let's assume that's the case. Yeah, let's just also pop the ECAS fittings in. Oh, they're nice. They're with metal. The ones I have are with plastic. They do have this plastic part at the back, but I think we can leave that on. Okay. You know what? Let's just do that for all four first. As I mentioned, I have a little bit of support still here. They just came hot off the printer, basically. And what I already know, so from the support here, the diffuser doesn't fit super well. So what I did with the other one, so I just basically like cut off like the bottom two layers there of this interface here. And then this goes on still quite stiff, but like a lot better. Then let's e-cast this one. By the way, what I already figured out, like they're quite weak in the middle here, like the parts. So if you press the ECAS fittings in, I think you should pay attention where you push. Okay, that's two. That comes off a lot better. That's number three. I think that's just what makes these MMU builds like so time consuming. It's like you have to do everything like X times. The support doesn't come out super nice. Okay, last one. Those two heat sets are for the step-down converter. Oh, well, it's in changing the printable spec. Okay, that's a very good tip, Mr. DSI, but I successfully used the long heat sets in this step-down converter part here. Like, these are the two. And they're identical to the other four. So I'm not quite sure why you would need different ones there, to be honest. Seems a bit odd to me. Okay. Then let me quickly like clean up a little bit. Let me quickly put all these like clips in the back. Okay, done. So we put the bearing, and I have that on the right side. Yes, this is the bearing. So let's just put the bearing in all of these. This one still has some mouse ears. Okay. I have one extra bearing. I assume that goes in the end piece. So what we need to do now, basically, we have the BMG extruder hardware here. Sorry, start throwing out empty bags. 1, 2, 3, 4. And I will not screw them in yet. Which orientation? They're going the other way. So I don't screw them in yet because I'm not sure about the spacing. I'm just going to put that together. Just make sure this runs smoothly. Like from the print, the top is a little bit flat here. Once it's in, it runs fine, but let me just quickly make sure that these are proper 5. Okay, then the next one. Then the next extruder part. Maybe actually before we put them in, let's add a little bit of thread locker. And make sure we put the right one in. Because this one is one without screws. One of the gears has no screws and one gear has screws. And we of course want to put in the one with screws. So the thread locker takes quite a while to set, so it's okay if we like later later screwed in. Put the other ones out, and I'm also sure that I take the correct ones. Okay, now I think we have everything in place, except that we put this one a little bit too tight. Then the next one. It's like a pearl necklace, one after the other. Okay, so these are all the gates. We can also already shoot through the 2 and 3 rods here. And let me fix the first and last in place, just like that it doesn't slide apart. And then I think the second one goes. Where's the second one? Here. Through these holes here. So that's a little bit less fixed. I think technically we can already align them. So I just have a bit of filament here. And the only thing I want to make sure is that it's like in the middle. But I'm not quite sure. Let's go check this overview. So it's not supposed to send out a lot on this side. Because I think this will just go in here, basically. Oh no, the second one actually goes through here. No, that makes more sense. And then this goes here. So basically we shouldn't have like a lot of the rods standing out on this side here. Okay, so this looks okay. Also looks okay. Okay. Then let's do the following. Let's put the M3 rods here in this end piece. I don't think we need threadlock for this. Hi there, hi there, Ravenkeeper. And now they're all lined up. And I think later the screws will pull it a little bit together. Let's see, there's a little bit of like a little bit of brim also here. Hmm? It doesn't want to be easily cut anymore, but it's okay. Okay, cool. We could have also added already the magnets here. Let's actually do that quickly. Because then I think these are ready. And we can add later the gates basically go in like this. I'm not quite sure which the numbering order is. I will copy whatever they have. So these go in here. Yeah, that rotates freely, so that is nice. Okay, let's quickly do the magnets. I wonder. Oh no, I don't wonder. This one goes. No, that doesn't go here. Interesting. So we have one extra bearing, and it didn't give us a single spare heatsink insert. So I'm fairly certain that we need this bearing somewhere. What was I looking for? Magnets. Where are magnets? Magnets are here. Now, are these good magnets? I'm not sure if these are the N52 ones. I don't think so, but let's use what the kit gives us. Let me quickly fix my camera a little bit because for some reason I put up the camera jig super crooked. Okay, so I just put it over the edge of the table here for a second. The magnets fit in relatively well. I still want to add a little dab of, oh no, not again. Ah, sometimes I super glue the super glue bottle. So I still want to add a little bit of super glue. And then I just use this thing here, just like to push them in, but anything flat works. Just make sure to keep the polarity the same. And these magnets are actually supposed to repel each other later. Okay, so the gates go on top here later, and they're supposed to repel each other. So basically we need to put it in this orientation, like opposite basically. So this needs to go in here. That this, yeah. This goes in here. Now this, exactly, like this doesn't want to close now. So it's like acting like a spring, basically. Okay. I'm still so happy that like this printed, like it's literally like 3-year-old filament, and I had nothing, like no spare left. I just got these like 4 gates out. Shit. Now which way? This way. Technically, you can scale this MMX to be like more than 4, but the default is only 4. I think the only thing limiting you is the camshaft. No Steve today. He's stuck between all his printers. Yeah, I think he just forgot time and is like busy with his printers. um, this is one of those one-step MMUs. Yeah, exactly. So we have these gates here basically on top, and then we have this camshaft here basically that pushes basically one of these gates down, and they're just like extruder gears basically in here, and the selected gate basically just connects the extruder gears and the others don't. So it's a very simple MMU. Part of why I like it, like it's not like a super complex build like a ERCF or something. Okay, let's continue with these. So for these, the idea is basically we have this 3mm rod that goes through here and hopefully fits in there. We need to see that that goes in there. And the gates are on there, but I assume for like long-term reliability reasons, what they do is they insert the PTFE tube here, and then basically the M3 rod goes into the PTFE tube. So I assume that's just like to reduce friction. I'm just like very roughly cutting these PTFE tube bits. Now I'm gonna use the knife in a second to cut them to size. I believe this is the only time we need this PTFE tube here. Let me quickly use a fresh blade. Nope. Just cutting those flush. Easier said than done. Okay. Let me quickly check what the number order is they have in mind. Did I kind of keep that? Oh, they don't show that. Let me take a very quick peek in Fusion. So the one that is near to the gearbox here is 0. So we are starting with 3 on this side. So we are starting with 3 on this side. That means we start with 0 here, actually. So 1 is the first one we have to actually put in. Then we do 2. And then we do 3. Now, let me just... If this doesn't quite go in, a bit hard to push. I do want to have this in a plastic on this side. I think now it is. Yeah, I think now it is. You know what? I just have a hammer here, so let me just carefully just tap that in. Now you also see the opposing magnets. So this is like very low friction here. I actually had to, when I initially put the PTFE tube into these parts, it was relatively hard to push the PTFE tube. And the manual says explicitly at some point, we'll talk about these gates. Yeah, so they say basically use a round file assembler to clean the tunnel so that 3mm ID PTFE slides in easily. I just used the 4mm drill and I just drilled it out a little bit until like the PTFE slipped in easily. Because like now you see that there's very little friction here on these gates. So I think this is pretty good. Before it was just like very hard because the PTFE was a bit pinched together. Looks like a fun one, yeah. Like I think it's a cool little project because it's not too complicated and you don't have like a massive expensive bomb. Okay, well I think all these parts are done. The only thing that smart people would have done is the end stop switches in here. We completely skipped that. I knew I would forget something. So yeah, we have to take this apart again. No biggie. No biggie. We can just slide these off. Bit of chaos here, but it's fine. Okay, let me actually also take this one off. The good thing is we now see this is connecting in the plastic. So, hey, I think maybe it's best to just start with this part in this state with these 3, and then you can slide in. So I think we're learning here. Okay, so I see one problem. So basically, as I mentioned, like these hole supports did not work out very well. So there's no hole here. And this is supposed to be 5 mm hole. So let me also just quickly use the reamer I have and make sure this is good. So looking at the manual here, so I do have these 5 mm glass bolts. And they were nice enough to give you one spare. So I can lose one of these. And we have the end stop switch. So let me just try to push this one in. Which is a very tight fit. Now the art will be to push them far enough in. I need to push a little bit deeper. I still see the writing in the holes here. But I shouldn't push too deep. I do already hear it click. If I insert that, I do hear it click. Okay, I still have to push like a teeny tiny bit more that I get the screws in. I think now it's good. And then we have, I think these are just the self-tapping screws. I did see a bag of them here. And these are 10, so that seems about right. I think we can. There will be other Bowden tubes in here for sure later, but for now, let's just keep this like stub here. Yeah, perfect. Like this goes very easy. With the teardrop shape on the hole there, be maybe better. Should be easy to slide in then. Yeah. There are no teardrop shapes on any of these holes. And also the supports are not that good. So yeah. I feel like you could optimize these parts a little bit more. If you want to. But I mean, if they're functional, they're functional. I'm not complaining. Okay, this is number one. Let's hope the others are quicker. Where are my fun little glass balls. Ah, you also have to pay attention to put the switch in the right orientation. Like there's it needs to align with the wall basically. I think I landed that one quite good. Yeah, the screws kind of pull it in the right depth. That's quite good. Like you don't have to nail that. The screws kind of like if the hole is visible at the end, the screws will pull it in. Okay, two. But I feel like this glass ball is quite a nice design for the filament switch. I remember in the V0 this was always like super inaccurate and painful. Also for these screws, like not a single spare. And the last one. Now you can put it back together. I feel like it's nice to just give a little bit of spare parts for these kits. Like, I mean, it's not really like the defining the price if you do like put like 1, 2 extra screws of everything in there. The price is mostly shipping. Yeah, that is true for most things that come from China. I mean, like they don't have to put in like a second step or something, right? But like screws, magnets, like I mean that doesn't cost anything. And I think you have a lot easier time to push it in there if you have an angle at the filament. Yeah. I don't hear the switch clicking all the time, but it must be must be clicking, so yeah. Let's see, we'll figure it out later when the switch is hooked up. Okay. Second time it's the charm, right? So then I need number 3. Actually, before I put this in, let me fix this in place. Where is that not turn? Oh, I know why. The screw is so far out that we need to put the screw on top when we insert that. Here we go. Well, so now it doesn't fully freely turn. It's definitely the screw that is colliding with the, yeah. Why is that not the case? That wasn't the case before. That is weird. Here it's fine. So I think it is something in this gate. Let me quickly use this gate for now. Because this works perfect. Then we use one spacer. Oh, before we do this, we need to put in the idler thing. Is this not in? Yeah, no, this also like touches. Why does it suddenly touch? We had it all together and it didn't touch. Then we put it together. I think it has to do a little bit with the shaft being loose. Let's just put it together, and worst case we have to take it apart. Because it did work just before, so I'm not quite sure why it wouldn't work now. Okay, then the next one. Then we need number 2. Oh, that's the wrong way. The ear needs to be on this side. I shoot some filament in that we can align that. Then we have the spacer. Now we have another gate. Yeah, now it spins freely. So I think it was just like that the shaft wasn't quite centered. Nope, I forgot the bearing. Mea culpa. Let's try this again. We have the last spacer. Oh, we need number 1. Then the last spacer. Then this one has the bearing installed. And number 0. Okay. Now we have it installed with the switches. That was quite a detour. Clipper macro for this one must have been really fun to make. Well, there's the happy hair, which is like the I don't know how to call it, driver for the MMU units, and this one is supported by happy hair. So that should cover most of it. Let's clean these out here. I think this is where our last bearing goes. Pretty sure. Let me quickly take a look at Fusion. So this is the mechanical thing we need to make. Yeah, there's the bearing. Let's see. Like mine does not fit like this because there's a lot of like filament that's not quite where it's supposed to be. So I have to work a little bit on that. Yeah, I'm not sure if it's my fault or if the model is not good there, but like the overhangs are not very nice. Yeah, that should fit. Okay. Yeah, I really have to squeeze it a little bit together to get to the M3 thread here. Especially this one is like barely coming out. That will be interesting in a second. Oh, okay, let me quickly take this out again. So basically what happened here shows me this one pushed basically all the way through here. So it was definitely not far enough in on the other side. That is not how it's designed, but I think we should not have a problem from that. But what I will do is I will like loosen these M3 rods a little bit here, that we can have them a little bit more out. Because at the moment I thread them in all the way on the end, and I think that does not work. Okay. Let's insert these again, and then we have to push the rod in. It would have been nice if this would have been a through hole here. It will be a little bit of like a... I love magnets. Okay. I will still use the hammer here to tap this in. No, now it's a through hole. It's not quite as designed. Let me quickly... So I'm just using the screw basically to align it with the rod. And now it's definitely in on the other side. And now it would also be okay here. So I'm not quite sure. So you have to put this in relatively deep on the other side. Otherwise it pokes it pokes through on this side. It's not like, it's more like a cosmetic issue than anything else, but it does annoy me. You know what? I will keep that for a second and later just super glue that on there. It does annoy me. And it's pretty hard to turn the shaft now. So I feel like there's a bit of a bend at the moment. So I think once we tighten these M3 things here, maybe it's better. Let's continue our journey for now. One thing I noticed, the manual doesn't say to put washers here under the M3 rods, but then the next step in the manual shows the washers. So we will put washers. And then we just have an M3 nut. My print is fine. Okay, well then it's me. As reach is only like my print fine as well. It's just that the overhangs are not really nice. You should have first put this one on. Yeah, now it gets. And the manual also says to not over tighten these, which I will of course not do. There's a little twist in this entire thing right now. I think that's also why the shaft is not really easy to turn. It could also be that one of these is, especially this one. There's definitely friction somewhere. Let me see. Let me loosen the gears for now. But even with this, I still have friction. Let me see. Single 515 toolets are on the low side terms of cooling. That is true. There's also ABS, so I don't think it needs tons of cooling. I really wonder where it is now. Like, there must be like alignment problem. Because I can also not pull it. Mhm. Until here, it's good. Yeah, okay, funny. Oh, is it the last bearing here? I mean, now it works. The fuck? Okay, don't ask me why it now works. And let me actually also put the three rods together. A little bit more. Yeah, that's still fine. There's a tiny bit of friction, but I think that is somewhat expected. Mhm. But if I not tighten this, like that definitely starts rubbing more again. So we need to be careful with this. There must be some alignment. The only thing I see is that at the moment it's a little bit like this. So like basically the bottom part needs to be a little bit pushed together, but like there's later plate here that will do that. Still should work smoothly. Printed the ABS parts with V0. No, with 2.4. Hmm. Quickly pull this out again. It's also like, oh, did it tighten it already? No, I did not. Did I? No, they're all loose. So right now it's like super easy. I think it's really the last bearing. But now again, it's easy again. It's really weird. Like I do something and then it's misaligned and it's not easy anymore. Okay, let's put it together. Yeah, also this one is now. This is free, but this one is free. But the last one here is a little bit seized up now. Oh, that was because of the screw, okay. Okay. CNC mod MMX. Yeah, that's the only way forward here. And now it's okay. Like I'm not quite sure, but something causes issues sometimes. Let's keep an eye on that. And I will also already put in the bottom plate here, because this will kind of pull this together from the bottom. Must be these screws here. This screw doesn't want to go in for some reason. Heat set insert is a little bit misaligned. Not sure if I screwed up there when I put in the heat set insert. Yeah, but now it's hard again here to turn this. Like it will work, but it's just like a lot of friction. I'm not quite sure where the friction comes from. Hi Daniel, welcome. For which printer? For the Switchwire. That's also why we have the yellow. Hmm. Okay, so I'm not sure what to make of this, to be honest. I'm not sure what to make of this. So 1 is fine. 2 is fine. 3 is fine. 4 is fine. But then I know that when I now tighten these, and like it will be fine, but then like at some point it will not be fine. Oh no, and this one has the problem again with the screw. There's also they're very close to this side here, the plastic. Okay, let's continue for now because now it's pretty good. What we're gonna print maybe I mean maybe, but the parts I checked they're not warped. The parts are all flat. Minus this corner here. This one. But this shouldn't affect the. Oh, but now this is also like not far enough in. Like I can't close that. So I think this is right now not in. Ah, yeah, it's not in on the other side in the bearing. Mea culpa. So, so this for the 1500th time. Yeah, this part is warped here on the corner, but I don't think it's warped in the area where the shaft connects. I did check these parts. I must have missed that. But this is a super annoying part to print actually because it has this rail around here, so there's very little contact on the outside. You know what? I will reprint this part just like for visual reasons. I will continue now the build, but I will replace it. Shrinkage between ABS and PLA parts. The only PLA parts are these 4 here. And they are for sure not a problem because they're not connected to the shaft here and they have plenty play. I will replace this part. The other one is straight for sure. And it also makes sense that it like goes a little bit like this because like these two rods, they're all on the top part. So it's normal that like it flares out a little bit. Yeah, this is easy-ish to replace later. So I will reprint this and replace it. I'm not sure if this will solve the issue. Because if this part would be the issue, then if I remove this bearing here, it should move freely, but that's not the case. Well, worst case, it we're in. I mean, it's kind of moving okay-ish now. I wonder if it would move better without the bearings in between here, because you have 1, 2, 3, 4 bearings that kind of constrain the shaft. So potentially it's just easier to have 1, 2 bearings at the front and the end. That might be one option. I'm really not sure what the problem there is. Because like mechanically the parts fit together quite okay. Okay. Where to continue? Let's maybe install the stepper here. That's kind of like the same tensioning mechanism as a 4 extruder, for example. But I'm not 100%. Like, I feel like we have a lot of these screws here. Not 100% sure what goes where. No, it's not specified what kind of screws they are. I guesstimate it's M310. Before I put this in, let's also apply the heatsink on the back. And we will have a little bit of fun with cabling, but we'll be fine. No, M310 is too long. Then let me do M36 here. That seems good. Maybe you get away with M310, M36, M38. Let me actually quickly try M38 if that's. Oh, for these, we definitely need the M310s because like here you have a hole where it sinks in and these are like on top. So let me grab where did I put them? M310. And we also need a washer for those. Two washers. I think they give you quite a lot of like extra screws on these like general sizes. So I don't see us using this many screws. Okay, and this is like kind of a little bit of like a tilting mechanism, and we can later basically use that to tension the belt. Okay, then there is this 80 tooth gear, which I think will go on here. And it goes through. And that goes. Does that fit? Yeah. So we basically have two pulleys. One of the pulleys we will sacrifice, so to say. Shouldn't lose cup screws. So this one we will sacrifice. We will install it here on top. Let me quickly see which orientation that goes on. So it basically goes in this way, but we have to remove this top. I'm not sure how to call it. Um, use different pliers. Here we go. So this top ring basically comes off, and we will not need it anymore. And then this goes in here. We also need to use the hammer just to tap it in. And then basically this is now connected. We have 1, 2, 3, 4, 5 button head screws, I think. I wonder if they want us to use these M38 self-tapping screws here. Let me give that a shot. Because that just looks about right. Yep, I think that's where the self-tapping screws go. Because you're kind of threading into the teeth of the idler. Why not just print the whole pulley? I can't answer that, but the M4 extruder from Voron has the same design with these half printed pulleys. Oh yeah, but you also say I don't understand why Voron does this pulley gear thing. Well, this is not Voron technically, so, but I'm pretty sure they copied that from the M4 extruder. It's just a different gear design in the center here. You've never been able to get those run through. Yeah, like I also feel like we had some, because I had the same gears printed at the Poor Man's Corkswire, and I feel like we also struggled there a little bit with getting them. How can this get now stuck on the shaft? Such a chaos here. How can this now get stuck? Oh, that's not 5. To me, it looks like that's the. I mean, it looks perfect, but like I think the whole of the gear here is not 100% aligned with the. I mean, now this way it works. Ah, now it works. Okay, well. Yeah, so that's the Rook MK2. So I just printed the whole thing. Yeah, well, if it works, it works. I actually like ordered like metal ones for the last time I used them. Because I had some inconsistencies and I wasn't sure if it was because of the printed pulleys or not. So I just replaced the whole thing. Yeah, it doesn't like it's okay to spin, but like it has friction. It shouldn't have friction, I think. Not a horrible amount of friction, but definitely there is friction. I wonder if it's this part here or not. I don't think so, to be honest. But yeah, let's continue for now, and then we will troubleshoot it a little bit later. And this one exactly goes in the opposite way onto the stepper. And then we can align them basically. One belt is 184 and one is 188. 188 goes over here. Put that first over. Okay. Now just like turn this a little bit to kind of align that naturally. And then we will use the two grab screws to lock this in place. And now it's way too low. Now it's way too high. Will I find the middle? Yeah, this is not good. Like if I now turn it, the belt stays roughly in the middle of the pulley on the motor. And I also put the belt screw, like there's the flat side of the shaft, the grub screw, and the grub screws on the flat side. Not hyper essential, but now it also feels okay from a resistance point of view. So let's just see. Like I think this is okay. Like a little bit of friction is kind of expected here most likely, but ideally would have been without. But like you're going through 1, 2, 3, 4, 5 bearings, So any minimal misalignment will cause friction. I was upset when I saw the belt said, yeah, like this is weird. Like, why not use the same belt? Replace 4 tooth is 8 mm of the whole belt run. Like, just put the servo like 4 mm lower and you're good, right? Okay. I mean, these are good. No friction there. But also this is fine. Like if I turn this now by hand, like with the 80 tooth, like it's fine. This will work. Just for my visual, we'll replace these later with some properly cut ones, just like putting them roughly to the correct length. Okay. Then the the servo. So this goes in here, and you can kind of adjust it up and down a little bit to tension the belt. But how is this fixed in place? Because like this does not mount M3 screws. Like we can put a washer and nut behind that. Is that the intention? And it's not modeled. Okay, then washer and nut it is. Because I don't think there's another way. And I will use a little bit longer screws here on purpose. Like they gave like tons of long screws. Nope. They gave tons of long screws, so I'm just gonna use I even forgot what I have now. M320. Let me get the top one in place. This would have been easier to do before assembling that. So maybe like mounting the motor to these plates before is like a smart move. I'm also like wondering, initially my plan was to just solder to these connectors, but if we now put the motor, we definitely need to do the connection points here before. So there are like these connection points in here for the wiring for the end stops. So I think we need to do those first before putting in the servo, because that will cover that. Wasn't there a trick with like JST connectors? I vaguely recall that you can use 5-pin. Oh no, just not wide enough. Because the hole spacing of the JST connectors is the same, so I mean it does fit. It's a friction fit, but it does fit. So maybe we can crimp JSC connections there, but I'm not sure if they're like far enough in. It does work with the how is it called? It's not only clicky probe, it's like for the mini self burner. I had this like attachable probe, and they used exactly that. They used the JST on these. Well, the radius should make it way easy. Yeah, exactly. Well, it's the whole point of this gear, right? I did a printed CPU belt and it stretched too much, but it worked for alignment. Yeah. Standard 188 or 200 belts. Yeah, this one is 188. The other one is like 184. It's not a high-speed printing MMU anyways. The stepper can surely handle it. Yeah, exactly. Yeah, I'm wondering, should we go for the JST or should we solder directly? I'm kind of like, I'm kind of in favor of the JSTs, to be honest. That is somewhat cleaner. Just make sure that they fit in all of them. Yeah, it's very hard to put these JSTs in though. Now let's just solder directly to the pins. I think that's also the intention. Let me quickly check out the wiring. There's the wiring diagram. Okay, so we are connecting. Now I need to remember which orientation I put the switches in. And I bent one pin. Yeah, fix it. Which orientation did I put the switches in? Um, let me see. The balls. Where was that? Where's it described? Here. So the ball is on the inside, and that's also where the switch then is. So it's on the inside is the switch, and the inside is ground. So basically what I need to do is I need to connect. I'm not sure how to show you that actually. It's like classic me, like I should have done it earlier. But there's basically, you know, the pins, so we need to connect all like these of basically with ground. They give us some silicone wiring. So I will just use the black wire for that. So I think the easiest is to keep the wire in one piece. So at the end, we can of course remove a bit of wire. And then we kind of space it. Let's see, so how far are these apart? So let's just say we space it like 40, then we have a little bit of like extra bit of cable. Using this kind of as a gauge, so somewhere here. And then I should be able to just do this and move it over a bit. And then we can solder this exposed little wire section. You just have to kind of like move that all a bit over. And now we can solder these gaps basically to the plugs. And then I think I will start on this side. Um, I will start on this side. So this will be a bit iffy with soldering, but hey, we're here for a challenge, right? And then I'll just leave some generous amount of cable. And we can add some crimp to that at the end. Yeah, the order of operations I'm doing here is definitely not ideal. I think, but it's also like if you solder these, like you kind of connect these gates to each other, which is also not ideal when you put it together. Okay, let me see. It's also extra fun now with the camera. So I will quickly take off the top here, mostly just for light. Because it's very dark there and I don't really see what I'm doing. But maybe also the access becomes a bit easier then. So I'm not really sure what I'm doing here. But also this becomes much easier if I do it like this. Okay. I have a bit of solder on all of them. And next I'll put a bit of solder on the cable. And then we said we want to start on this side. Not sure if that is a good connection here. Maybe a tiny bit more solder here. I should have also used a smaller soldering tip. Maybe I have to change it. Hmm. This one's also the smallest gap I have here. Maybe this gap is a tiny bit too small. Let's add a bit more solder to that. Here we go. And the most fun one for the back. And most likely you see nothing but my hair. But I'm very sorry, it's very hard for me to see. It's very hard for me to see. Wait. Try to do it a little bit more here than you can see from the front, maybe. Yeah, sorry. I need to bend over that. I don't see anything else. Otherwise. Okay, so these are connected. So this is kind of like our ground chain, so to say. And then I would use the, it doesn't really matter, green or blue cable. Let's just say green is our end stop cable. Let's just make this somewhat the same length. Classic me. Now I have 3 cables, but I need 4. So I added a little bit too much cable. But to be honest, there is more of this green cable here for the LEDs. We will just use blue for the LED. Oh, but this is thinner. Oh. Uh, wait, I think I have matching cable. 1 second. We will solve that. Yes. I mean, lucky me. Most likely comes from the same factory in China anyways. No, this one is not. This one is not good. The others look good. Okay. With that out of the way, we can install. Oop. We can install the motor. Okay, but let's do what I wanted to do. So basically we use a longer screw with a washer and a nut. Oh, wait. Wait. The goodie bag of the servo comes with these. And I think this is kind of how you want to put it together. There's a rubber ring. Hey, Loki. Aha, and then from the front you have these self-tapping screws that go in here. Okay, so there's this rubber thing. Oh, minus one screw. That one is unrecoverable. No, that's not the screw for that. That's for the... If this goes clean through, how is it supposed to be mounted? That's a good question. Nobody's happy, no CNC today. Yeah. The last days, or like last streams, I mostly had him parked at my neighbor, but it only went good for like a couple of times, and then he got like always super bored. Attend the Church of the Flux. Yes. Comes with a certain amount of flux. Adding flux. Yeah. I know. I also have flux. I'm really not sure how am I supposed to mount that, because like these screws are not good for that. Like they go. And they for sure thought of something here. Well, I'm not sure, but I will stick with my approach. But I do use these rubber things. So I also see there's a hole missing. Okay. And then let me throw on some washers. I like with the hardware provided, I don't see any way mounting that here. So this must be somehow. This is the only way I see. Let's put it like this. Okay, so 4 washers applied. Two nuts. The last one is really tricky to get to. But we managed. Whew, okay. So we can still move this up and down a bit. Yeah, so it's basically just like screw and then washer and nut. Yeah, it's awesome. Yeah, I have to reprint. This part needs to be reprinted. This did not go well. I did not notice that. Okay. Now we have all the cabling hanging around. Then, this is the gear for the stepper. This comes with a screw, but I think it's just the M3 screw. Let's just use it anyways. If that's long enough. Yeah, should be long enough. I don't think it's long enough. It is long enough. Okay, we also need to pay attention in which position the servo is. Okay. I have 2 of these bearings, but I also saw a couple of these bearings. I'm not quite sure yet where they go. Um, where do they explain the camshaft? They don't really explain the camshaft bearings, to be honest. I think these two, they're also too small. I think these are for the tensioner here. They're for this tensioner. And I think these, exactly, this goes here. And I'm pretty sure, yeah, there's also like in this cover piece that we put on later, there's one here at the end. Which doesn't want to go in. I can't really push it in with all the parts in here. The third one, I'm not sure where this is supposed to go because this is too wide. And I saw installation video. I'm also quite sure where this small part goes. Um, so this goes in here. We need to be careful with the position. And we also still have to add the counterparts for extruder gears here. But if we put this in here, so basically we can activate. It's a bit weird that it doesn't go into the bearing here. Actually, huh. There you can see now basically we can activate gate 0, 1, 2, 3, 2, 1, 0. So that works. But before we can install the camshaft here, we have to install the bearings. But I am a little bit out of time now. Because like 9 is always like a little bit the end of the time I have to stream. So I would install this plate here. And then I would say we continue next time with the camshaft and the electronics. That also gives me time to reprint the warped part here on the side. And then hopefully the friction is out of the system. So I was already like wondering like how long does it take to assemble it? Because like, it looks relatively straightforward, but it is quite a bit of steps and the manual is not amazing, which is not helpful in the slightest. But we do have all the core parts kind of assembled. Yeah. I think the friction is not a problem. Like even, yeah, like with the 4-to-1 toothing here, like this is fine. And I'm pretty sure it will run in a little bit. So this should be fine. And then the other thing is like, I'm really not sure why this does not go in the bearing. Wait, I do have these two bearings here. I have one left of those. That is curious. Like it doesn't. That does not fit. That does not fit. That's weird. Not a printed part, it doesn't fit. That is just, it doesn't go in. That is weird. So there might be some issue here with the bearing or the shaft, one of the two. I remember I had also a very hard time inserting that here. But like according to my calipers, the shaft is just under 5. Okay, well, that is something I need to figure out. Because like if that doesn't fit, I mean now this one fits a little bit, but then also doesn't come off anymore. Not quite sure what to do with this. Okay, cool. Well, then for me to do, reprint this part. You see here, basically the corner is kind of like warped in. So I will reprint this part and we'll kind of take this off and reassemble that. Yeah, and then next time we continue basically with the BMG gears here. And then with the camshaft, hopefully with fitting bearings. Try remount the bearing. It's actually like an excellent idea. I think it is. Because this is how far it goes in, and the reamer is undersized on the tip. So the bearing is too small. That is an interesting problem to have. We can think about how to mitigate that. I will think about that. I don't have any other bearing at the moment, but yeah, cool. I count it as a success. We're not done yet, but we will get there. Yeah, enjoy your weekend and see you next week. Bye.